Hello everyone.
Good afternoon.
Yeah, good afternoon. Okay. Uh, so, is there anything, or is there anything you wanna explanation or something like that? Because like in yesterday's class, I think we covered almost everything. This session is not being taken by Ashish sir. He won't join. This is like if you have any doubts and all, you can ask for this quiz too.
Sir, I want to ask one question only. It is not related to the theory or anything SK learned. The difficulty level of quiz 2, it is similar to quiz 1 or it is more?
Difficulty level.
Yeah.
So almost similar, but in this like decision trees and this random forest and all comes in, right? So
Uh,
uh, it's a kind of increases the complexity of questions and all.
Sir, could you give the brief summary of all the concepts and brush up all the concepts in this session?
All the concepts. Okay.
Brush up main concepts of quiz 2.
Yeah. Yesterday I did, right. I mean, it's same
Yesterday
thing.
we did questions, etc. No?
Questions.
sir, he asking he's asking about the practice question, something like that.
We've given you mock and all, right? It's similar, like the it will be very similar to mock test complexity of quiz 2. But the thing is, you have seen mock but not quiz 2. So
Yeah.
it depends. Like there will be some changes, right? Not same question you're gonna get. You need to think through and all. Um,
So can you explain one versus one and one versus just classifier ones?
yes. Okay. So 1 versus 1 and 1 versus rest. So what happens is, let's say we have uh, 3 categories. Say red, I'll not put this thing, red, blue, and green. Okay, these are the categories of class, like labels, target labels. Okay, and we want to classify this. We have the data for it, and these are the classes. So what we can do is, one thing we can do is we'll create so first thing I require multiple classifiers, like one classifier means inside one classifier there will be multiple classifiers that will work. So that's why like this 1 versus 1 and 1 versus rest concept comes in. If it was, let's say, binary, then only one will suffice the job. if it was binary classifier, like binary targets. Binary targets are there. And so let's say binary targets means red and blue were there. These were like binary targets. And we create a classifier, right, that will give us is it red or blue. But when we have three categories like red, blue, and green, then what we require? Like we need to classify red or blue. So basically we need to classify red, blue, and green, right? So let's say first I will take one versus rest. One versus rest, we create a classifier that will identify red and versus rest. So rest will be what? Green and blue. And then I will create another classifier. I will just name it classifier red. I'll create another classifier blue. This will identify the blue, but and again it will on the opposite side it will be other categories like red and green, right? And I'll create one another classifier which will tell me is it green or not. So green versus rest. Rest will be or rest or all. Both have same meaning. Red and blue. Red and blue, right? So this is like one versus rest classifier. And one versus rest classifier. How many classifier we created? Three, right? Three number of classifier we required to classify this three label problem. If it was like 5 labels, then we require 5 classifiers internally. Okay, internally we require 5 classifiers to classify that problem, to solve that problem. So number of classes will be same as labels. Would say what should I say, proportional is equal number of classifier required, right? But I can do one more thing also. I can create one classifier which will tell me if it is blue versus red, like blue versus red, I can create. And again, like everything, like blue versus green, and list goes on like red versus green, red versus blue. So I will require like NCR number of classifier, right? More will be there. Write it down. Green versus which one we missed. So blue versus red is there. Blue versus green is there. Red versus green is there. And green versus blue, I guess that's all remained. Okay. So how what it will be n into n minus 1 and minus 1 by 2, I guess, or yeah. So we had 3, so 3 into 2, 6. No, n into n minus 1 will be 3 into 2, 6. We created 5. Yes, and minus 1 minus 1. If anybody of you remember the formula, you can skip it. you recall like N and you have to choose R, something like NCR. If you are familiar with that.
Sir, blue
Yes.
versus red and red versus blue are two different things, right?
No, it will be one only, right? So blue. So that's what. No, like let's say I take blue. I will compare it with blue and red, and then another blue with green. Then I need to compare red with green, and green versus blue is already there. So three only required. Okay. So I guess then I was right again. 12 minus 1 divided by 2. Okay. N star n minus 1 divided by 2. I take it. It will be 6, right? 3. So if I have let's say more classes, red are the B and Y also there. Then let's say I'll compare red and green, red, blue, red, Y. Then if I compare G, B, G, Y, and one more will be B, Y. Okay. So we require like 3 plus 2 plus 1. 5 plus 1, 6. So 6 classifier will be required. 6 if n1 versus 1. 6 classifiers. But if it was going to be 1 versus rest, then 4 only required. 4 classifier, 1 versus rest. This is like 1 versus or OVO. Yeah. If it was OVR, then we will require 4 classifiers. Okay. Understood?
Yes, sir.
Okay. Okay.
Sir, what all we have covered so far, sir, apart from this classification?
This
This
is all.
only we have.
Pardon?
This thing
Hello?
only we have.
Okay, okay, okay.
Okay. So, how this CD classifier works? Usually, what we do is when we take the all of the training data, and then we compute this step to move towards the bottom of bottom of the curve for cost function, right? But in SGD, we do it in stepwise manner. Like we can do in at a one step at a time. We can do in batch also, like 10, 20 samples. After that, also we can go down, and all of the things will also work. So like there are 3 things in SGD. Like one step at a time, which is called one sample learning or something like that. Sample learning, batch wise learning. This batch wise learning is there.
Sir, batch is there, mini batch is there. There are two kinds.
Yeah, mini batch and batch. Okay, thank you. And mini batch. So usually batch we take all, like all means batch. Okay, all the samples means that usually. Okay, and mini batch is we take out some rows out of it, some smaller than batch. Smaller than batch, all of it we call mini batch. Batch. And one sample is like one only. After one sample, we take the and down for learning cost function of it.
That is the default behavior of SGD, right, sir? Which is basically
Correct.
one sample at a time.
In sklearn, this is the default one. sklearn.
Okay,
In
thank
sklearn, this is the default. By default, and like if you want to do many mini batch and all, then it's not that easy. I have seen it. So this national regression linear model, each sample at a time, and model is updated along the way, decreasing strength, schedule, aka learning rate. Okay, so it allows mini batch, online out of core learning via partial fit. So if you want to do mini batch, then you need to do this partial fit to make this mini batch. And batch is also same, like you have to do partial fit or something like that. Okay, what we have, okay, it supports this. Okay, not much, but this is important one, like what how to write this different kind of algorithms using SVM. So let's say if you want to write SVM with SGD kind of thing, then how to write that. Okay, so let's say learn dot linear models. Okay. So we need to choose a loss which we want to do. Let's say if I want to create SVM out of it, by default it is SVM only. Hinge is SVM. So you can create a hinge in this. Okay. So maybe you have noticed somewhere that SVM usually takes more time to converge than other linear models. If you compare it with linear models like logistic regression or SGD is also there, and other like KNN classifier. If we are talking about classifiers, if it's like classifiers and all, then usually SGD, the SVM takes more time. But if you use SGD classifier loss hinge, which is SVM, it will take lesser time than that. It will improves what you say, time complexity or something like that.
Sir, so hello.
Yeah.
Yeah, so SGD classifier with loss equal to hinge, does it execute linear SVM or any other SVM? Like we also have this kernel option in SVM.
Correct. Kernel options are there, but it applies like linear SVM only. But I
Okay.
think kernel it can do. Mm, okay, no, we can't do, but it's like linear SVM only.
Okay.
Okay, log loss. Log loss, if you use, then it will be like similar to logistic regression. Modified Huber is another smooth loss that brings. Okay, it's not. Okay, perceptron is also there. Like if you want to create a perceptron, Then you can use, if you want to create perceptron with stochastic gradient approach, then you can use SGD for creating it. And I guess this the losses was squared error. Okay. As well as regression. Okay. Then this penalties, like L1 is lasso, L2 is ridge, and elastic net is like L1 plus L2. Okay. Penalties, alpha value. So here alpha, if we increase the alpha, then it will start making the model underfit, right? If we have low alpha, then it will overfit. Just remember that low alpha means overfit and high alpha underfit. Opposite to SVM C parameter. C parameter is opposite to this. Like if we increase C, then it will start to overfit. But in this case, if we increase alpha, then it will decrease the overfitting. Reduce. Okay. L1 ratio is same. Max iter is there. How many like maximum iteration you want to do over a epoch, right? Or one training data. I guess it's all are with beta 0 is like initial learning rate. And if you want to set okay, I think there was nothing specific which I should okay. I mean this was pending like yesterday's class we didn't cover it, so I thought I would cover it today, but everybody I guess familiar with SGD. It's not that like you have to see it and practice it. You will know what it is. That's all we have in this. Okay, in this what we have, same thing. Okay, so in this, like you can see epsilon insensitive is used as a SVR, not Huber. So I'm I guess we have not studied what is this Huber losses and all, maybe, and it's not important for now for this course or this quiz also. But if you know that whichever is used, that is enough. Like what it is, how to create.
So just a small, so just a small doubt. I think in SGD or logistic, somewhere we use refit equal to true or refit equal to false. So what does refit stand for? Refit, R-E-F-I-T, refit.
Refit, yeah, refit we use in SGD only, I guess.
Yeah.
Where was it? Should be okay. Zero refit. We have seen it. You are right.
Leave it. We can discuss towards the end. Continue with your.
Yeah, but like I don't remember it exactly what we do with that, so I was just looking for it. If you know, if you can read it somewhere, then that's okay.
Okay,
like,
I will try to figure it out.
Yeah, like all this parameter, even after some time, just slips off the mind what it is.
No. We are just worried from tomorrow's exam point of view. Anything can come.
Yeah, correct. But if you search for it, then you will get it. Something like that.
Sir, I believe the refit is related to something related cross validation, maybe. Because after cross validation, let's say we do not test, we have to test the validated parameters on the whole data. So if you set refit to false, maybe it will not. And if you set refit to true, then it will use those parameter after that the output from the cross validation, and it will test it on the whole data and give you an average score or something like that.
Okay. So yeah, and I get it. I think that's true. Scores are average across all folds, and the coefficient and the C that correspond to the best score is taken, and final refit is done using these parameters. Means you are correct. Like, so whatever parameters we got using this hyperparameter tuning or this CV, we take those parameter and again refit the model as a last final model. Okay. Okay, what should we cover next? Is there anything we should cover?
Sir, I have a question. So if you can take that. So
Yeah.
do I share the screen? Means I have to
You-
show you it's from past question.
Okay. Yeah, go ahead.
Sir, meantime, Subodh is sharing his screen. Just a small request, sir. Week number 6. Hello, sir.
Yeah.
Yeah, please kindly upload the relevant collab file, because the collab file which is uploaded in the supplement content that deals with some heart related data, whereas professor has taken some other file.
Not sure, but I can look into it. Okay.
No, I'm sure, because I have recently revised. I have revised yesterday only. So I'm sure. Yeah.
Okay. Yeah. We'll discuss
Yeah,
more. Yeah, sure. We can discuss that. Yeah, go ahead.
So, sir, in this particular question, so when they mention regularization parameter, right? So,
C.
so it's C inverse of regularization parameter or the C as a parameter in itself, which is basically equal to alpha. First confusion I have.
So C is
Because they,
inverse proportional to alpha, or
so
yeah.
yeah, so they have not mentioned the algorithm, right? When if they had mentioned, let's say, reach, we know C is basically alpha. Means that's how. So I'm quite confused how to deal with such type of question in the exam.
A, B, C corresponding to find out which of the following option represent the relation between. Okay, so rigorous parameter. I think this question should have something like which algorithm you should use,
Yes,
because
yeah. Otherwise, it is left to the interpretation of the person, right?
correct. And like if I tell you if they have taken this sklearn only, then C parameter is only been seen in SVM, not any other. Like in other we call it alpha or something, but not C.
Logistic regression also has C, right?
Logistic regression.
Because alpha is I found alpha is more rare. C is common.
So yes, the logistic regression also has C.
Yeah, it has C. Okay.
So and so here it says regularization parameters CA, CB, CC, and the only place we've seen C is the inverse.
Yes, and
If they would have given alpha A or alpha B, alpha C, then we could have taken the directly proportion. So it must mean the inverse regularization parameter.
And yes, what Deep says is completely right. So if we take the inverse, then the answer is right. If we do not take the inverse, then we have to change the sign. So it will be CA greater than CB greater than CC, depending upon the MLT theory.
Correct. But
C
okay.
is the inverse of regularization parameter. I think this was discussed.
In MLT, if I remember correctly, increasing C leads to overfitting. Something
It
like
restricts
that.
overfitting.
So in both the cases, this
So if
SVM and logistic regression, in both the cases, C is inversely proportional to alpha.
Yes.
So Even in logistic regression, if you want to increase the alpha, alpha means this penalty,
Regularization.
you have to actually reduce the C.
Yes. So, what do you see from this? Is the answer right or wrong? Means it is left to the interpretation. Again, what I'm trying
No,
to
no,
say.
no. You have to see where decision boundaries are. First decision boundary, how it was being formed, and how many outliers are there, or how it is going. Outlier means which didn't come in the decision boundary, correct decision boundary. How it is dividing the data. Then in B, how it is dividing the data. Uh, of positive and negative classes. You have to see the decision boundaries. More finer, more regularized.
Yes, right. So more simple, more smooth it is, more regularized, right? So more
No, no,
regularized means
no.
more
More
higher.
regular. Sorry, more regular, more simple. Correct, correct.
Yes, right. So higher the regularization. Let's take alpha from theoretical perspective because it has been treating me very badly. So if I have alpha from MLT, so higher the value of alpha, I have stronger regularization and smooth
Correct.
and simple boundary, right?
Correct.
So that in that regard, the CA must be highest
CA must be highest.
because that is the smoothest. Then CB, then CC. The
No,
more
no, no. So C
complexity.
is inverse to alpha, right? C is inverse to alpha.
So that is the confusion, right?
C
Because
should
what
be
to take?
smallest.
Just because they have written C, should I assume it is inverse alpha?
Subodh, if it
Because
is
the
not,
term.
Subodh, if it is not assumption, it has been discussed. If you ask proof, I will not able to prove, but it has been discussed that C is the
Okay.
inverse of alpha.
Okay.
Yeah,
But
C is even in this SGD regressor, C is inverse of alpha.
Okay. So
Sorry, logistic regression.
okay, again, if no algorithm is mentioned, because again it changes from algorithm to algorithm, we will, if I see C, so I would assume it's the inverse of alpha, right?
Correct. And
okay.
if they are using sklearn, so think that it is given from sklearn only for this course at least. And in sklearn, C is defined inverse of alpha. So wherever you see the only C parameter, that means inverse of alpha.
Yes, then only the answer is correct.
Correct.
Okay.
But sir, that assumption is correct, but how to approach this question? I'm not able to see also the picture properly. I think it is a bit blur for me. So how to approach this question?
So
how to okay.
So I can
can't
explain,
see
sir.
the classification.
Yeah, you can explain.
Yes,
Okay.
please explain. Yeah.
They can't see the class photo properly.
Yeah, I can't
Yeah.
see the photo.
Yeah, I am saying
it's
the same
blurred.
thing that I am not able to see properly, so I don't know how to approach this one. Yeah.
Acha, so if the photo is not visible, then it's quite tricky for me.
But anyhow, you
Because
go on. Yeah. You go on.
No,
Whatever
the
we are
photo is
saying.
clear. Photo is clear, and in
Okay.
A, B, C,
Yeah.
so number of misclassification is diminishing from A to C.
Okay.
So decision boundary is becoming complex from A to C.
It is becoming complex from A to C, right? You are on that. Everybody is on that.
No, one is blue dot. What is the other dot? One is blue dot. I
It's
can
yellow.
see.
Yellow.
Just
It's
look
yellow.
at the
Blue and
decision.
yellow.
It's yellow. That's why background is white. It might be tricky.
Yellow is correct classification, is it?
No, anyhow, let it be any classification. We are
No,
segregating.
no, there are two classes, yellow dots and blue dots,
Right.
and there is a decision boundary which kind of separates yellow dots and blue dots. Blue dots. So in A there are more number of misclassification, and from A to B it is the decision boundary is becoming a little complex and misclassification reduces. In C it further becomes complex and further reduces the misclassification.
But Bimles, if I am able to see some big white circle in A. So there are three blue in yellow dot, right? So everywhere I can see three or four misclassification kind of thing. So yeah, leave it. I am not able to see properly, so I will not waste my time.
So remember, let's forget about how much classification, misclassification. Let's read the question. So just restrict ourselves for the time being because of time constraint to different boundaries, right? We can see a circle is simple, right? That you can see, the boundary you can see, right? circle being the simplest, then when we transition to B, it's getting complex, and the C is the most complex decision boundary. Is it true for you as well, right? And do you see that, GP?
Yeah, yes, we did. Yeah.
Okay, so now when we have, let's go back to MLT because that's the crux. So in MLT, remember we always have a loss function, then we have alpha, and then our coefficients, right?
Mm-hmm.
So that is our alpha, our regularization parameter. So if we increase our regularization parameter, you remember the coefficient will become tends to 0, right? Because they want to regularize the overfit.
Mm-hmm.
So as the coefficient tends to go to 0, less and less dimension will come into play. And the simpler the curve becomes, because less taking care of the other features. Do you see that?
Yes.
So now alpha is done, right? You understood alpha.
Mm-hmm.
So if I have to take the answer of alpha, then alpha A is greater than alpha B is greater than alpha C.
Okay,
But
the
now,
C is inverse. Yeah.
now
Okay.
when we go to C, that switch flips. Make sense?
Okay.
Please repeat about alpha, Shubhadeep.
Okay, so let's say linear regression. We have our MSE squared loss plus alpha times L1 or L2, whatever you can take, alpha times
Yes.
some type of, right?
Yes.
So as we
Yes.
increased alpha in MLT, the coefficient has to go down to tackle overfitting, right?
Yes.
So that's why when we increase regularization parameter, what we have in theoretically in MLT, the coefficient decrease, and the more the coefficient decrease, let's say we had 10 features, and by increasing regularization parameter, 5 of the features coefficient goes to 0, means those features are now out of the equation. And because those features are out of the equation, now
Yeah,
our
in
decision,
L2 they will become less relevant, and L1 they will become 0.
yeah, I'm not even trying to complexify thing with L1 and L2, but in both the situation, yeah, in L1 it will be more sparse, but both the situation, the more coefficient will go to 0. Let's not go
Right.
into L1 and L2.
So decision boundary will be simplified.
Decision boundary will be simplified just because less features are taking part in the creation of the decision boundary, and thus tackling overfitting, right?
So yes, got it. Got some insight. So you're saying that circle is easier, simplest.
Easiest,
Yeah,
right?
simplest.
And now the issue with me was C and alpha, what to take, because different scale and algorithm talks about different thing. So I just wanted to verify that.
Yeah.
See,
That's
No,
thank
but
you.
then when you are saying, so in case of A here, alpha is greatest.
Greatest from the MLT point of view, from the
Correct.
theoretical
So
point of
when
view.
alpha is greatest, then decision boundary will be complex or
Simple and small.
simple.
Simple and small.
Okay.
Because less features are there, right? Think about it. Straight line is the simplest you can have. Even if you go to point, a single point is the far simpler. Then we go to straight line.
Shubhadeep, one question.
Ah.
See,
Yes,
in sklearn, the alpha we put, the higher the alpha, higher is the regularization.
In certain
sklearn,
algorithm,
not
right?
MLT. In sklearn, right? There are two parameters to control regularization. One is alpha. If alpha is 0, basically that means there is no regularization.
No regularization.
If alpha increases, that means regularization is increasing, which is
Yes.
the exact opposite behavior of C. Higher the
Yes.
value of C, lower the regularization. Is that correct?
Yes.
Yes.
Yes. Yes.
So in this case, the first one, basically regularization is not there, the circle.
No, it is highest regularization in the first one.
Yes.
Highest regularization. That's
Highest regularization, which is why C is the lowest.
Yes.
Yes.
Yeah, correct. Okay. Thank you. Good.
Okay.
Thank you.
Thank you.
Subhadeep. Thank you.
Sir, you can go ahead. I'm sorry to take so much of your time.
Sir,
Yeah.
I just want to share one slide from week 5. I just need some clarification. I'm not able to understand whether there is typo error or I am doing some mistake. It will take less than 1 minute. Huh? I'm just sharing.
Yeah. Sure.
Just a second. Okay, carry on. Let me open that file. Right, carry on. Sorry.
I think he's on break.
Okay. Then-
Sir, is your slide visible?
yes, yes.
Sir, here it is one versus all or one versus rest. I think both are same, right?
Yes, both are
In,
rest.
in, yeah, in the next line it is written that one versus one. So whether it is a typo error or it has something to do with like OVA is again written one versus one.
No, it's a typo. One versus all is basically OVR and OVA is the same.
So one versus one is a typo, right?
Yeah. It should OVR and OVA is actually the same thing.
Okay, no,
And
Basu,
here
that
it should have been one versus one, O versus V. You're right.
OVO. Yeah, now
Correct.
let us move to next last two line. OVR is implemented by one versus REST classifier API. This is clear. But one versus all is implemented by one versus one
नहीं वो भी
classifier.
typo है उधर it should be OVO.
अच्छा ये पूरा स्लाइड टाइपो है ठीक है
हाँ
ओके
basically OVA should be OVO everywhere.
चलो ठीक है थैंक यू
Are not at all. Sir, I have one question which I put up on discourse also on that decision tree. Somebody wrote, but I couldn't understand, sir. Can I open that and show?
Sure. That.
It's from one of the AQs. Sir, in the mock exam was like it took exactly 20 minutes to solve that, not even that much, and like most of them were fairly straightforward. Sir, if keep the exam also like that, sir, please.
Yeah, it is going to same complexity, but a little variance, like little bit different will be there, like questions.
No, after OPP1, I mean, these reassurances don't matter. We can expect anything to come.
In OPP, I guess you were last time also there, right? If I remember.
Yes.
And it was same as last time, right? Was it
Yes,
like different than that?
No. And this time I performed well in OPP, but then it was not as per the preparation.
I mean, okay, so see, when you have collab and all, we have taught you like most of the thing, but like it was small thing, right? Based on something, you have to divide the data.
Yeah,
You
but
have
then if you are
learning.
asking so many do so many things in a tight time span, then and with all the limitations of the portal, that time span may not be sufficient. So I couldn't solve last three questions, even though I knew the answers.
Okay.
Sir, I think most of us agree with Bimles, but in the interest of time, let us proceed with quiz 2 preparation
Okay.
because
So
already a parallel.
I am having
yeah.
trouble with opening discourse. I don't know whether others are having problem.
Already a parallel thread is going on for OPP1, so I'm sure people will take some call in the favor of students.
Listen, guys, can somebody open the discourse? This thing I'm having trouble opening. I'll just show the question. That was like it's quite important with respect to bagging.
You tell the question. No, what is it about?
It's about that features here. Remember, the question was, if it is a continuous variable, when you do bagging of features in random forest, you can repeat the feature if it is continuous. That's the answer. I don't understand why it should have to be continuous if you have to repeat. Right? Why can't it be discrete?
It is in week 8 something. Yeah, got it.
Right?
Let me find out that question itself. Yeah. In the meantime, you can discuss with sir. Let me find out that question itself.
I can. Okay, if you have. Okay.
Sir.
Yeah.
Hello, sir. Actually, sorry, 1 second. Sir. I was trying to just check my internet. Sir, I have few fundamental questions about this entire gradient boosting and random forest. Basically, the ensemble. If I can just clarify those questions. So, random forest doesn't build depth of trees, right? It just aggregates stubs. So it's just adding more stubs, right? It's a horizontal increase in. Basically, it's adding trees horizontally, not vertically. It's not building depth. Unlike, let's say, a gradient boosting algorithm like an like any of these, right? Gradient boosting or AdaBoost, it will build the depth of the tree. Is that correct? My understanding.
Okay, so what you are comparing? So if let's say it is a boosting algorithm and versus bagging algorithm. In bagging, we have multiple trees. Okay, multiple trees or anything. Some like voting classifiers are also there, which comes in bagging, and that like you can use different kind of classifiers also, like not decision trees particularly. You can use any classifier, but in random forest you have to use definitely like trees and all. So again, like bagging versus boosting, the difference is in boosting, we learn from one stump, a small tree with one max depth. Like depth is one only, or two, I would say, like two, right? Two depth, yeah, with two depth, right? That is stump. We learn from that, then we enhance the misclassified point further, enhance it, like we have this calculation and that we enhance it, and then we give it to another stump to clarify that, right? Like if it's also unable to do it, then again it will also amplify the misclassified point and give it to next stump. So that is how boosting goes on. But in bagging, we create multiple trees, or let's say we create multiple trees. Okay, then and then we take some feature and some rows, like not all feature, not all rows, some feature, some rows, and they can be repetitive possible. Repetitive column is also possible, repetitive rows are also possible. Okay, so we take that and create a tree, and then again we go to next, another tree will create, another tree will create. So let's say 5 6 tree we have created, then we take the vote out of it, like do the voting, what should be the class of this row or something like that. Is it clear?
So in boosting, I got it. Basically, we're adding stubs, and every time it's kind of, upweighting the misclassified, and that's how it's learning. Right? In that case, which features are being used every time? All the features are being used in every iteration.
In boosting?
Yeah.
Okay, in boosting, first time every feature will be used. Okay, then after first stump is passed, this features will not be same. The entire thing will be changed, like to some other values.
Okay.
Sir, one doubt here. So if it's a decision stump, then only one feature should be used, no? For the first stump.
Good question.
For stump, one feature should be used.
Is it one feature or one depth for a stump?
Stump, like it's just one branch.
Depth, I think depth is one.
Depth is one. What is he's saying also is correct, right? When you are only splitting it one node, you will only use one feature to split.
Oh, yeah, okay, you are correct actually. We
Or
use
actually, you can use combination of features also, right? I could say it is higher on X1,
Yeah,
lower on
that's what I'm saying.
X2.
Depth is one
That
in
also is
MLT.
possible.
In MLT, it was taught that for
Yeah.
stump it is one depth. Depth is one.
So this, I don't know. I mean, I missed that last session. I'm planning to see the video, but we haven't covered these ensemble methods in detail. There's too many things under it actually.
No, it is not covered in that great detail. And Vasu, I think you are talking about, sir, you can go to activity 8.1, question number 6.
I've got it. I'll share. Can I share my screen?
yeah.
Yes.
Sir, in week 7, we have not got any collab related to voting, right? There is no collab on voting.
So this question, sir.
Yeah.
Week 7.
Question number 6.
Week 7. I'm not. Yeah, Vasu, go ahead.
This is the question, sir. There are three options. That you cannot use a feature variable twice in a path and decision tree for splitting the data. It is possible to use feature variable twice if it is discrete. It is possible to use feature variable twice if it is a continuous form. I mean, Anand wrote back. I mean, I didn't understand what he's kind of trying to say.
So with discrete, they are discrete. So let's say what we do usually is when we have this categorical feature, we make it like as a one hot encoder or something, so that features will be in different columns now. So multiple features will be there, and if you think now, then for each feature only one, it can go one time only, right? One time it's required to split the data.
Correct. So even for my thing is that you cannot use it irrespective whether it's continuous or not continuous. See, because continuous, let's take a continuous variable, like let's say height, and at some level I said less than 5 height, you make it whatever left, and greater than, right? Then I come down. Can I reuse it later again to split? Because I've already used it once. I mean, I don't know. It's not very clear.
If it's a categorical data, okay, and so finally what happens is, if let's say you have applied ordinal encoder, not one hot encoder, 0, 1, 2, 3, 4 is there, then this decision tree will take it as a regression or a continuous kind of data, and it will split according like mean of 2 number and something like that, right? Between that kind of splitting will be done. So that feature will appear more than once in splitting the data.
Yeah,
if you apply ordinal encoder, but if you apply one hot encoder and you make different columns, then it will only appear once for splitting.
Correct, sir. But see, the question doesn't specify all that, right?
Yeah. Basu? Sorry, carry on.
Go ahead, GP.
Yeah, I was having the same doubt. So what you were saying that for continuous can't be used second time. Why not like whenever we were drawing in MLT classes a different kind of boundaries. So I think we have used a feature multiple times. At least 2 times we have definitely used. But just extending this logic, sir, what you are saying that in case of discrete, you are assuming that it is categorical variable and we are doing one hot encoding. But say, for example, we are taking number of defects. Now, number of defects is a discrete number, it's a whole number. Why can't I use it twice? That is the reason why I had also opted it for discrete and I got a wrong answer.
Okay.
Are you getting reverse? You are saying that it is a categorical variable, you are doing one hot encoding and you are getting 0, 1, something like that, and we can use only once. Your logic is absolutely correct. But my point is that, say for example, I am dealing with a case where number of defect is one of the feature and number of defect is always a whole number which is discrete in nature. So I can use it twice. So ideally both B and C should be the correct answer. Are you getting my point, what I'm trying to say?
Yeah, what you are saying, that's what I said. If you apply, let's say, ordinal encoder is like same thing, number of defects. 0, 1, 2.
Why I will do ordinal encoding? Say, for example, number of defects produced.
See, don't apply ordinal encoding. Just think that values are 0, 1, 2, 3, 4. Okay.
My number of defects. say for example 20. One feature is having number of defects. So number
Okay.
of defect
There's
is
some
20, correct?
explanation here, guys. Sorry.
Number of defect is 20. Why can't I use it twice?
No, you can use that twice. It is going to be used twice.
So
But
if I can use twice, then option 2 also becomes correct, no sir, in that case.
correct.
In
It
that,
will be, see in sklearn it will be used twice, thrice, or as many times, because sklearn don't know that this data was not continuous.
Sir, I just shared one post. They're saying I have to read it. They're saying basically if it's discrete, it won't be used. It can be used twice, but not in the same branch. It can be in a different branch. I can reuse it. If it's continuous, I can use it any number of times in the same branch, right? I'll have to review it, but somehow, sir, my only request is, sir, genuinely, I know you guys, you all work very, very hard, but if the question, the wording is confusing, we get confused and then we lose marks, and then we'll, huge battle on discourse will start. Exactly like what had happened in business analytics, right? Even last time quiz also, there are one or two things which are very confusing.
which one? Yes.
Yeah, I can actually show. I'm just saying that because there's still time.
No, coming back to your point, like if it is continuous, then it can be used any number of times in the same branch. What does that mean?
I have no idea. I've shared the link. I just got the link.
Then if you could explain further on this, then that will clear the doubt.
Hello guys. So I have shared a link from MLT class, okay, where Karthik sir took this decision tree and splitted it on a Cartesian plane. So maybe that can help with the visualization.
Yeah,
So
I looked at that. I know exactly what you're talking about. I looked at it, but I can't see why in that case also I can't reuse it. But it may not give you anything useful, but what is stopping from reusing? Anyway, that's one question. I just wanted to show you one thing, sir, from last quiz, if you can just hold on. I wanted to clarify it also for my understanding.
Yes, sir. For collab, what are you saying? That VK talks about decision tree and ensemble techniques, right?
Yeah.
So we don't have any collab on voting. We have collab on all the topics like bagging, boosting, ADA boosting, but we don't have any topic on voting.
Sir, can I share my screen?
Yeah, please.
Is voting in being taught in class? Any week? Can you give week number or something?
Yeah, it's in the slide, sir. Week 8.
Week 8, yeah.
Slide.
Week
8. Was there any collab used in the session?
No, collab was not. That's what I'm saying. Na? Is there no collab or we are missing?
No, if it's used in the this content course, which is taught by Ashish sir, then there will be a collab present somewhere. I have to search for it.
Okay, yeah.
So before this term, this whoever was in charge of this MLP, they didn't used to give this collabs and all. They used to give this PDF only.
Yeah, but
So
anyhow, sir,
somewhere like
I got your point. But anyhow, for week 6, sir, please upload the relevant collab because the collab is not matching with the collab which is used in video lecture classes.
Okay.
Sir, this question, sir. For example,
Okay.
the second one, I think GP had the same trouble.
Yes.
I spent a lot of time thinking about it and I then didn't mark it.
Yeah, you are right. We already discussed about that, right? This question was a.
Achha, you discussed. Yeah, I maybe I missed.
No, discuss with whom during our live session or among yourself.
I discussed with you only, Vasu.
No, sir. Then that was that we had not arrived at any conclusion.
I think we should move ahead. I mean, if something further needs to be covered, let him cover.
So you're saying this was an error, sir? That's what you're saying? I can't recall.
Correct. We gave mark for this. We gave mark.
Okay. So we are like some of the questions we're getting confused because the wording is. That's all I'm requesting to just take a look.
Yeah, sometimes
Yeah, I know, sir. It may seem obvious to you, but somebody else it may not. So I understand the problem. Just
correct,
saying
correct.
that.
So when we create these things, it looks okay to us, but not to others. I
Yeah,
understand what.
I know. But just yeah. Anyway, I thought I'll just mention that. I understand what you're saying. Good,
Sir,
good. Back to you.
coming back to tomorrow's quiz, sir. Like, sir, in K nearest neighbor, sir, when we have to create an object, right?
Okay.
So, professor has used both the classes. Like, say, for example, I'm creating an object called KNN to use for nearest neighbor, right? So he has used both the API like K neighbors classifier and
Okay.
nearest neighbors also. So can we use both?
No, I will show you. What we can do is.
But professor has used both, sir.
Yeah, correct. So this is the collab in which he used. I have it. I can show it to you what you mean.
Correct. I
So
mean
what-
only then what is the correct answer? Yeah.
okay. Right. So let me explain what does mean. K neighbor classifier. It is a classifier, like that is a KNN algorithm you learned. KNN algorithm in MLT. Okay. It's being implemented on the data set. Now there is something called nearest neighbor or something like that.
Sir,
Nearest.
are you sharing something, sir?
It's not being visible. Wait.
Yes,
I
it
think
is visible to
so.
me. You should pin his screen.
That was only used for the distances and indices to get the distance and indices, for dot k neighbors.
That's what I was going to say. Like this will useful for counting the this distance and all, distance counting and all. And one is KNN imputer. Like, don't confuse. I'll just put it here. It uses almost same thing, but it will be helpful for imputing. You can use it, and it will be you have to import it from sklearn.impute. This both will be present in this sklearn.neighbor. Right. So the nearest neighbor will give you distances and indices of nearest points to the one you want to find out. So let's say we have this data set.
But sir, he created an object using this.
Yeah, we have to create object, right?
Okay.
So let me show it to you what I mean is this x and y. Let's say we have it binary classification. Okay, I don't want to do that. PCA is also okay. So here we have Canon. In this, I have created a K neighbor classifier. Okay, just don't want to do this. It's confusing. Okay, here you can see this neighbor sklearn.neighbor nearest neighbor, and this neighbor we created object of this neighbor nearest neighbor. You see
Yeah,
this?
so what is the objective of this line? Like neighbors equal nearest neighbors, n neighbors equal to 3.
Yeah, I will. Okay.
You're right. You're right. Yeah, this one is correct. Like here we are using nearest neighbors as a class.
Okay, right. Now what I can do is there a train test split?
Because we are passing the value of k also, I think. No?
Train. So we have done train and test split here. Okay. Where was it? Here somewhere. Okay, here. Found it. So this is classifier. Okay. What I will do is we'll write something like this. neighbor dot fit, and I can give explain. Yes. So do you see there is no y required? I mean, first thing is y is not required. Labels are not required. Okay. Now, let's say I have this x test. This okay. This is the point. Okay. This looked like a big point. But I want to find this first.
So nearest neighbor is unsupervised, you are saying.
No, it's not unsupervised. It doesn't learn anything. Like, what do you say? Unsupervised, we create clusters and all, right? That's only we call unsupervised. But what it is it's just calculating the neighbors, like distances and neighbors.
Sir,
Okay.
that concept. Hello, so that concept is clear that KNN doesn't learn any model; it uses the entire data set, right? I am just
KNN
asking. I'm just asking the difference between these two class K neighbor classifier and nearest neighbor. I know it may be a very trivial question, but I am not clear between these two classes.
Okay, I understood. So
And neighbor, so nearest neighbor is only calculating distance between the k equal to 3. Sorry, supplied k number of k, correct?
Okay.
correct. So what will happen is, see,
So
I
is
have
it
this
like
right?
k nearest neighbor is using this nearest neighbor algorithm within itself?
Yes, it is easy. Yes.
Okay, okay.
Right. It uses to calculate the distances of the point. Okay, so k neighbor require it to calculate distances of each point from another. So now we have distances of each point. So let's say if I give this 1 point, okay, and I want to find out, give me the nearest 3 points to this new test point. Okay, this test point is new point. Let me write new point only. So it's a new point. I have it. I want to find the distance of this point from other, like nearest point to nearest 3 point to this. Okay. So what I will do is I'll write dot what is it? No, it won't work. Predict it. I have to write it's test 0 neighbors. I have to use this k neighbor, and I will give my new point to it, but okay, nearest neighbor is not fitted yet. Call fit with appropriate argument. But I did. What am I missing? Something.
Sir, have you done 11?
What 11?
Cell 11, have you?
This one?
Yes, sir. Can you run that? And then run the 18.
Yeah, sorry, I didn't fit it, and it was okay. So now we can see that this using this neighbor, which is not a KNN classifier or anything, it gave me neighbors to this new point. Okay, this new point is I taken from test data, which it didn't learn. So now it is telling me these 3 points. Okay, so what we are getting here.
So first array is of distances and second array is of indices.
Correct. So I'm getting distances, right? And this array, index. Okay. How to get? If I put this here, then I will get. We can like really write something like this also.
Okay, so it gives a tuple of distances and indices.
Correct, correct. So which one is the nearest point to it? This right? I can
The first
see which,
one,
which
the
one is.
first.
So let's say if I write xtrain dot ilock and give this one by array, so I will just directly give it. So this is the point. This is the point which is nearest to the test point, new point. Okay, and this is the farthest one among these three, not from all of it.
So many features are there, huh?
Not that many. So this neighbor is there, right? Inside the neighbor, you have to write key neighbor. That's all. Like one thing. Inside that, you will get these two things: indices and
No,
distances.
I'm just saying the 0.53843, that index number. So these are basically okay. This is the point, no?
Data set. Data set is of size 60, above 60 or something like that, right?
Right, right, right.
Shape of X train is uh, shape won't work. Like
60,000, I think.
yeah, it was 60. I know, but we did it.
60,000 is the row, no?
Yeah, 784.
60,000 is for extent only, and
And 784 is a feature. Yeah, that's what I'm saying. Yeah.
yeah, 784. And in this 60,000, this row number
Yeah,
538
that's what I'm saying. Yeah, yeah.
was the nearest.
Got it, sir. So you're saying that nearest neighbor is basically a class to find out the distance only, and
Correct,
K neighbor classifier is the algorithm. And sir, then what
correct.
is
Can
this?
you just go up a little, sir? Neighbors dot.
Here,
No, that index you got.
index.
53843.
Yeah, these are indexes, right?
Yeah. Neighbors dot. Okay, so that basically K is 3, which is why we got 3. Okay.
Yes.
So this nearest neighbor is an algorithm which is used internally in k nearest classifier. Before classifying, it kinds of needs to calculate all the distances basis the k supplied. So there this nearest neighbor comes into picture, and that because it is only giving you distances, there is no predict method on this. This is an
Correct.
intermediate step in k neighbor classifier.
Sir,
True.
one question, sir. That K neighbors you've given, that is the object, right? You've called?
Ob no, object is like this thing, right? We create object of this class.
So that's what. Acha, neighbors. Okay.
Is
Okay.
the object.
Neighbors
Is
is
the
the
object.
object.
Yeah.
Okay. Okay.
Yeah. Sir, in line with that, there is one
So
more.
if neighbors is the object, then K neighbors is the
Method.
method. Okay, got it. Now I got it. Clear. Thanks.
Yeah,
Sir,
key neighbor.
there is one more class, K neighbors transformer. So what?
Yeah, neighbor transformer or K.
What does
neighbor
it do?
transformer.
What does it do, sir? K neighbors transformer. What does it do?
Never.
You can refer activity question 7.3, question number 4, sir. Activity
Activity.
7.3, question number 4.
Here I have, right? Okay. Transform X into weighted graph of X of K neighbors. Everything is similar, but it transforms the data to this. What happened? We have to create an object of this. Right, guys. Okay, I created this transformer and I'll put in as T and I will put empty not fit. Shouldn't.
It may take too much time. We can take some smaller data.
T is not defined.
No, you'll have to rerun the collab.
Uh,
Just do run all.
okay. Is fetching the multiple times. Yeah. Okay. That actually. Not printing it. So it, like what it does is it transforms the data, but why? I'm not sure about that.
GP,
Okay,
if
leave
you're
it, sir.
okay,
Leave it,
GP,
sir.
if you're okay, we'll move on.
Yeah, yeah. Let us move on.
Sir, I have one question in the box, sir.
Box
Mock. I don't know whether it's already discussed. If it's discussed,
from the mock. Okay.
Yes,
Yeah.
sir. I was asking, is it important for the exam perspective that key neighbors transformer?
No, it's not important.
Okay, okay.
sir, I'm sharing my screen, sir.
Yeah. But this K and then K neighbor classifier and regressor and this neighbor, these three are important.
Okay. Sir.
And with that radius something was also there.
Yes, yes, radius key neighbors. Yes, I've seen that.
Oh, the solver problem. Yeah, actually.
Sir, this one I couldn't read. I'm not saying it's right or wrong. I'm just saying Newton CG. I thought was the like the square root finding thing. I thought this was like that approximation which it uses, right? Linear Taylor series. But I couldn't get anything on this, like how is it SGD? I mean, I tried to read the documentation, so I'm not sure why this is SGD. This was one question, and there was one more, sir, which I got it wrong. This one, sir. By increasing the max depth parameter in distance, likely
Okay,
to
yesterday we discussed like answer is wrong. B is correct answer.
Abba. Okay.
Which one, sir?
This one, 21.
This
Yeah.
question.
Yes.
Okay. These are the two doubts I had. Thanks.
So this first one about solvers, even like I have never learned the solvers or all, and then it's not been taught to you also. So
But questions keep coming, na, sir, which solver will be used. So
you can
every
like
term,
remember the things and all, like not logically there is something, but you can like just remember it if it's possible. But we are not gonna ask you anything like that. It will
sir,
be
are we supposed to get questions on default value? Like so many default values have been discussed at KNN also.
Either I'll do ini mini mini 1 0 or auto.
So many default values have been discussed. This algorithm has this default value, this default value.
What is the second question, Vasu?
The decision tree, question number 21.
As we increase the depth of the tree, so it is
It
likely to be
overfits.
overfit. Sir, one quick question, sir. What is this?
21 question, Biblesh.
Yeah. Sir, one quick question. What is this parametric or non-parametric supervised learning algorithm? Like, what do we actually mean? Supervised and supervised
Very
is
good.
clear. Supervised and unsupervised is clear that supervised comes with label and unsupervised doesn't come with label.
GP, parametric is basically when you're estimating some parameter, right? Like logistic regression and all. If you take KNN or decision tree, there is no parameter estimation. There's no probability distribution you're looking at. You're just
I
is
had
non-parametric.
done that for decision. I think for KNN it is showing something different. That
No, it's a mistake there.
Its definition is not matching. That is the reason why I asked this question.
KNN decision trees, these are all non-parametric.
Correct, no, it's non-parametric, right?
Correct.
But in one of the activity question, I think that the answer is not matching.
Yeah. The slide clearly says it's non-parametric.
But the answer is not matching.
Yeah.
By that definition was clear. The underlying, objective of asking this question was tending to that question only.
Yeah, you're right.
Sir, in logistic regression, or I think SGD, even I have also forgotten, somewhere we have written a parameter normalize equal to deprecated. So what does it mean, normalize equal to deprecated?
if it's written means sklearn in future updates it will remove this feature.
No. Literal meaning of deprecated is clear, but why we are passing that parameter, inside the algorithm? We have used this as a parameter. The literal meaning of deprecated is clear to me that it will be phased out over a period of time. Now,
Not sure why, but you can, if you show me where it is, I can.
So many collabs are there, sir. Now it's very tough.
No, if it is anything is deprecated, so that collab when it was prepared, it was in use. Now it is deprecated.
As in that method used to be there earlier now, or method or whatever variable. Now deprecate in the sense it's not used in the latest version.
Basu and Vimlesh, what I'm saying, the meaning of deprecated is clear to me. I'm saying this is passed as a parameter itself in the algorithm. So within the parenthesis, हम pass करते हैं ना, this equal to true, this equal to false. So there it has been passed. Normalize equal to deprecated. This is passed over there.
That is okay. No, I mean, in the collab they kept it as a parameter, but it is deprecated. So there is no meaning in using that parameter.
Okay, fair enough.
Sir, I have one more question for the past paper, if I can just share my screen.
Yeah, sure.
Yeah, maybe others have solved it, they can help me. So this question, sir, I mean, I guessed it based on, the hint given here, but what exactly is happening in this case? That's what is not clear. There are a couple of questions like this in the past papers, like what exactly is happening? Because we are asking for prior probabilities again, that's why the score is 1, or what exactly is happening underneath is not very clear. I mean, not just question to you, sir. Everybody, anybody who's understood this can help me.
Okay, so what we have to predict is
so the answer is 1. But what is exactly happening is not very clear.
I can say that what I am seeing is we have trained on something, and then we are telling our model to give score of that also. So it is going to give you one output.
Not necessarily, no, sir. So training data set, you always get some score which is not necessarily 1. But in this case,
but this is not parameter. Okay, this is here. This parameter, non-parameter comes in the picture. Where we have parameters, parametric methods, there it's not possible, not true. But non-parametric methods, it is going to be 1.
What does that mean? So here it is categorical naive Bayes.
So
And
decision.
But this is parametric only, sir. It estimates the probabilities, prior probabilities.
No, yeah, no. We don't create any generalized model or something like that. I guess category. Okay, this is parametric mode, but where we create these generalized models, like generalizing all the points, generalizing the model, that's where score is not going to be 1. But if you see this category like naive Bayes and what we have KNN, then decision trees, then that is going to give you like score 1.
Why so?
Because they they tend to learn everything which is given to them, right? Like they don't generalize anything. They don't create any model. Like in linear regression, it has to create one model, like y is equal to w0 x1 w. So now that equation will be useful after training the model, right? But in this cases, like there is no formula after.
Okay, so you are saying that all the data which has been fed to this algorithm has already been compartmentalized, and when we are asking for the same data point from the sample already fed into the system, then it is just going and looking into that compartment and returning the value, which is what is happening here.
Correct.
Okay. No, but then how to know which one will do what, sir?
So this linear models, they all generalize it, but which don't. This decision trees, they don't make any generalization or.
So if it is a SGD classifier, then
it is like it is a linear models, right? SGD always create one formula.
Sklearn dot linear model. Understood.
Sir, related to this bagging and boosting, are they applicable only for tree-based algorithm or other algorithm also?
No, they are applicable to other algorithms also, but in random forest specifically we use trees, but we can use other algorithms also.
No, but in all those algorithms, mainly decision tree is being used as a primary estimator, no?
Correct.
So doesn't it mean that they are only applicable for decision tree algorithm?
No, I mean you can use other algorithms.
Other means what? Can I use that with linear regression?
Yeah, you can use it. So for bagging, let's say bagging is there, right? You want to take the vote of different classifiers. You create classifier, multiple classifier, and you take vote out of it.
No, I'm talking about the linear regression. I'm talking about the linear. Hello, linear regression.
Yeah, so let's say linear regression.
Yeah.
Okay.
I am predicting the price of a house.
Yeah. So let's say decision tree regressor is the first one. Okay. First regressor. It gave output as 50,000. Second is linear regression. It gave 51,000. Third is SGD regressor, it gave 52,000. Now what will happen is we take mean of this all, that will be 51, and that will be the output of the whole. Are you clear? Like we take mean in regression problems.
But again, we use decision tree, no? Again, we use decision tree, no?
Again means
Yes,
we want.
that's what I'm saying. That bagging and boosting are mainly using decision tree.
Yeah, it can use so no, what I'm saying is inside this bagging there will be multiple classifiers, right? But let's say 1 2 3 decision trees are trained, and two other classifiers are there, let's say linear regression, SGD regression. Okay, then what we'll do, we'll take this all 5 of the regressors and take mean of this 5.
Okay, so you are saying that both these techniques can be used with any algorithm. However, random forest is only suitable or only used with decision tree.
Yeah, random forest is like when they created that algorithm.
Number of
it's
trees, number of trees, yeah.
Yeah, they use trees only. That's why they specifically named it as random, for like gave the name.
Yeah. Forest is a color. Yeah, ठीक है.
Yeah. Okay.
Hello, sir.
Hello.
Yes, I have some questions. May I share my screen?
Yeah.
Is it visible?
Yeah, it is visible.
So actually, I was asking from this question. Here for the precision recall curve, it is told that the graph plots the precision value in the x-axis and the recall in the y-axis. But in the fifth slide, the precision recall curve is given that the x-axis has the recall and the y-axis has the precision. So say something.
Okay. Okay.
He is correct, sir. In fact, there is a
So
doubt in.
if you are correct about this, then you are correct. Like then this question is incorrect. I mean, answer is incorrect. Where it is
Sir.
in mock.
Sir, actually, there is a slight challenge there. See, if you actually interchange and draw, the curve doesn't change because it's not symmetric, but it's this, like typically the values are, it doesn't change the graph. But if you read the documentation everywhere, what he said is right. Recall is always on the x-axis. But for some reason in the collab, Sir had used recall on the y-axis.
Sir has used both the options.
Yeah, so actually it doesn't make any difference to the chart, but everywhere in the documentation, usually recall is on the x-axis. So we all ticked x-axis.
But is this option correct? If this type of questions come, what should we do?
We'll go with documentation, Arjun.
Okay.
Okay. Go with the documentation, correct.
Documentation says the recall should be in x-axis or y-axis?
X-axis.
But the recall is in y-axis, it is even correct option.
Yeah, that's what I'm saying. This is wrong. If you see, I mean, it's not technically wrong, but if you go by the documentation, it's wrong.
Okay, got it. Can you explain this point also, that probability thresholds, different probability threshold, it compares pairwise?
Wait a minute.
The other day we had this discussion.
Actually, I can see your screen, but what I am seeing is just blank.
The screen is not visible, right? Screen is not visible.
Okay, I'm sharing.
Actually shown a collab the other day and explain how it works. If you want, I can repeat. Hello.
Yeah, hello.
Hello.
Ajay, the other day we were discussing this. I had used the threshold and I had shown it. If you want, I can repeat it, if that's the question.
Okay, can you, yes, it will help if you show it.
See, typically logistic regression or any of these classifications usually have a default threshold, right? So in logistic regression, if the probability is 0.5 and above, it classifies that data point as class 1. If it is less than 0.5, it classifies it as class 0, right? Let's just stick with binary logistic regression, right? So right? So that, but that threshold is default threshold. It's not sacrosanct. You can change it, right? Typically, for a
Okay.
certain threshold 0.5, it would have classified some as 1, some as 0, and from there some will get misclassified. Some positives will get classified as negatives, some negatives will get classified as positives, and from there, based on that, you can calculate the confusion matrix, right?
Yes.
False positives, true positives, and there
Okay.
you calculate the recall precision scores and all of it, correct?
Yes. Yes.
Now, if you change that 0.5 to 0.6, let's say, now
Okay.
all this classification changes, right? There will be probably more number of cases which go to 0, less number of cases which go to 1, right? Again, you can create a confusion matrix for that probability threshold, and then you can again calculate precision and recall values.
Okay.
Right?
Then I can generate different precision recall curves by changing
Yeah, so
the.
that precision recall curve, every data point there is a combination of precision and
Okay.
recall
Okay.
for various thresholds.
Different. Okay. Okay. Got it. Got it.
That's the point.
Yeah. Got it. Got it.
Basu, did
You
you get
can't
some?
see the threshold there. For that, you have to run another function and get the values for precision, this thing, and threshold. It will give you a vector array, and from there you can figure out the thresholds values. But it's not obvious in the chart because it's a two-dimensional chart.
Yes. It's a 2D chart. Okay. Okay. Got it.
Vasu,
Huh?
did you get some insight related to that ROC underscore curve and ROC underscore AUC underscore curve?
Basically, what you said is right, GP. They're the same.
But again, professor has used both the functions in many places. Like somewhere he has used ROC underscore curve, somewhere he has used ROC underscore AUC underscore curve.
Yeah, see, basically what I realized is ROC is that ROC curve, yeah, which is basically your false positives and true positives, right?
But yesterday when
Now,
I was going through different collabs, I have seen that professor has used both the options. In fact, in one place, one of the heading itself is that ROC underscore curve versus ROC underscore AUC underscore.
yeah, so what I've realized is when you use the AUC, you use it for purpose of comparing two models, right? The more area there is under the curve, the better the model is, right? So you use the area under the curve concept to compare 2-3 models and choose which one is the best. That's what I've realized, but they're both the same technically.
Sir, could you throw some additional light on this? Like, are they same or different? Because
Sorry.
ROC underscore curve and ROC underscore AUC underscore curve. For last 2 days, we are discussing on this topic. So
Okay.
we are.
So what happens is ROC is same. Like ROC, you create this ROC curve, okay? But when we want to classify which is better, like if you have two ROC curves and you want to say which one is better classifier, then we see area under that ROC curve. So the curve is formed. Now we see area under it. So from X to if you know integration, something like that. But we take area under that curve, that is AUC, and ROC is receiver operator characteristic. So if AUC is high, then we say that is better classifier than the other one. Okay, so ROC is same, but ROC AUC you use it when you want to compare the models.
Hello, sir. I have two more questions. Can I share my screen?
Yeah.
I have. Is my screen visible?
Visible.
Kind of black.
Yeah, visible, but it's showing like CS. This on CS 2008. It is Gmeet.
Okay, I'm resharing it once. Okay.
So what is this Ravel function? RAVEL Ravel function.
Revel will convert 2D or 3D matrices like array to 1D.
Sir, what I request, sir, after quiz-2, sir, kindly navigate us through these collabs. In spite of doing fresh coding, we can navigate through these collabs.
Okay. I can see, but it's blank. Arjia.
Okay, 1 second. Sure. Is it visible now?
It is still blank. I think you will have to click the option share full screen, something like that
Yes,
option.
I'm sharing the entire window. Sharing the
Not
entire
window, full entire screen.
Entire
Share
screen.
entire screen.
Entire screen, yes.
Okay. Oh, okay, got it.
Yeah,
Yeah.
entire screen. That I was saying.
Now
Yes,
it's
entire
visible.
screen.
Okay.
Yeah, it's coming. It's coming.
Yeah.
It's
I have a
appearing.
I have a confusion in this question. Is it visible?
Yeah,
Yes.
it's visible.
I was saying that if I up to the value 6 of k, I think the validation error is decreasing. So the validation error, if it comes
This
to
is
this
for
point,
K. K means
yes, it's KNN. It is KNN error.
K.
Okay. So I was asking that in point 3, I think the graph should be underfitted, na, right? Because it will be overfitted after point 6 because the validation error is increasing.
Okay.
So I think in the point 3 it should be underfitted, but the correct option is overfitted. Yeah, value 3.
What is just
But,
that slow down, okay?
The training error is low, na, at k equal to 3.
See the question, he is using k equal to 3. At k equal to 3, it is
The training error is low.
The training error is low, but
And the validation error is
training
high.
error is low, so it is overfitted. No?
Then so it is
Overfitting, na?
overfitting.
okay, if the training error is low, then it should be overfitted. Okay.
Yeah, basically it's overfitting on the training data. It's not able to generalize well on the validation data.
Okay, but the validation, if we increase the value of k, the validation error is decreasing. So when the validation error increases, then it should be overfitted, right?
No. See, overfitting, this curve is for training loss and validation loss.
Okay.
So, trailing loss is less at k equal to 3, but
Yes.
validation loss is high at k equal to 3. So, at k equal to 3, it is saying the model is overfitting. Now, if we increase the k to that converging point, say k equal to 6, then both are kind of optimal. Even the training loss is increasing, but validation loss is decreasing. So, generalization is better. After k equal to 6, again validation is loss is increasing, so we shouldn't increase beyond k equal to 6.
Yes, I got that point. But it is it. I am not getting that point of overfitting. That I've got the point of
Training
6.
loss is less, validation loss is more, so it is overfitting.
Okay.
That is the only
If
guiding
training loss is
principle.
more, then it is underfitting.
Okay, got it.
That is the only guiding principle. What he is saying.
Okay.
Yes,
I got it. Yeah. And last one, can you explain this one? Because in this question there is regularization, but the other question there is no regularization, there is no penalty. So with the regularization, the bias should be low, right? The bias should be high. Actually, this
Bias should be higher, variance should be lower with regularization.
okay. Only this confusion. Okay, thank you.
Because
Sorry, just say that again. If
because
you
of
regularize,
regularization,
you regularize better,
so
the
bias,
model will
the variance will go down, no?
it will not overfit basically.
Yeah.
So it will have low variance. It
And-
can have high bias, but right?
Yes, high
We
bias.
don't know.
yes. Bias will increase. Bias will increase.
Bias
You're
will
right, also. What is the option? What is in option?
Option is model B. It's given with
Just
the
to show again.
regularization.
Okay.
Can you make it full screen? Sorry, I can't see it.
I can decrease the size.
No, I can't see it. So increase the size.
What do you want actually?
Increase the size. That's all.
Okay.
Yeah.
It's correct, right?
Yeah.
Yes,
So what happens is when we apply regularization, it will underfit. It will start to make it underfit, right? And whenever something is underfitting, what it means is bias is increasing. It's not able to learn properly. That is bias increasing. Learn properly or learn if learning is getting lower or underfitting, then that means bias is increasing. And we can't say about
What is the meaning of bias is increasing?
Bias is increasing means it's not able to learn properly. Learning is not happening properly. Underfitting.
Sir, according to my logic, if we put a regularization, the variance would increase, right? Or I'm wrong?
Variance will reduce.
Variance
Variance
will
will reduce.
decrease.
Okay.
Yeah, if it's underfitting or overfitting, in both the cases, variance will increase. And in this case, we are putting now like L2 is there, right? We are penalizing it. So it will gonna regularize and variance will decrease.
Yeah, got
So
it.
this-
Bias will increase. So model B is the correct answer. Yes.
But the question is based on bias, and
Yes.
bias is like learning. When model is not able to learn properly, that's when we will say bias is increasing. Learn properly means earlier it was overfitting, right? Learning properly, learning. Just think of learning. Forget about test part. Learning part was better, but now we are penalizing it for learning better. So that's when we are having high bias.
So kind of like we are penalizing it for uh, memorizing on the training data.
Learning
So,
too well.
so it will not be able to generalize well on the test data. So
Correct.
that is why we bring into regularization, so that
Correct.
I mean memorizing the training data or the bias in learning the training data becomes low.
नहीं bias को मत जोड़ो. Now don't learn bias here. Whatever you had said till now, that was correct. Now bias will increase. Now when it will learn less, you are penalizing it for learning more. So the moment it starts learning less, bias will increase, na? Because it is not hitting all the points. Correct. So bias is increasing.
Does it always mean when we penalize, the bias will always increase whenever we penalize? I mean,
Yes.
whenever we
Yes.
use
More,
penalty.
yes.
Yes.
Ideally,
Always.
it will increase a little. Matlab, not, yeah, it does. It moves in that direction.
Yes, it moves in that direction.
Without the penalty, it will try to fit all the points. Then
Correct.
the variance will increase and the bias will become low.
Bias will increase, na man.
Or bias will increase.
Is it?
Sorry.
Yeah,
No, if he's saying regularization nahi hai, so that's correct.
yeah.
Without the regulation.
Yeah, that's what L2 will increase the bias when in the model A it is given as none, right? So we are not regularizing, so it will not have any
Yes, sir.
increased bias.
Yes, right.
That is the answer, right? Which
Yes,
I
sir.
mean, this
Model
answer is
B-
based on the penalty we applied here for this
Yes,
question.
so bias will increase in model B. Yes.
Okay. And one more thing, I mean, does L2 penalty will always be higher than L1? I mean, bias in when we use L2 penalty, will that always be higher than when we use L1 penalty?
No, L2 is actually mod and L1 is square, right? Last
No,
question.
sir. L1 is mod,
L2
L2 is square. L2 is
हाँ,
square.
L2 is square, no sir. Yeah,
Okay.
L2 is square, L1 is mod, absolute value. So,
L1 is square. That is going to be higher, right? In terms of penalty.
yeah,
so
that's
it
the
depends.
reason
No,
I'm asking. So
it
L2,
again depends on certainly alpha. Na. Alpha value is also there. Na? Provided alpha value is same in both cases. So penalty is more in case of L2.
L2, no? That's what. So squared value will have more bias.
Yes.
Okay. 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 Thank you, sir. Thank you, GP.
Okay. Then okay, guys. I'm
Thank you, sir.
goodbye then.
Thank you, sir. Thank you so much for the
Thank you, sir.
session, sir.
Thank you,
Thank
sir. Thank you.
Sure. Thanks everyone. Bye bye.
Thank you. Bye, sir.
Bye, sir.
Could anyone share the YouTube link for this?